Hello class, welcome to this course, Introduction to Python Programming Language. Python programming language is a popular high-level programming language used in various applications. Python is simple and very easy to learn because of its simple syntax. It can be used for simple tasks such as plotting or for more complex tasks like machine learning. So it can be used to develop different applications, smart-based applications that involve the use of machine learning and its subcomponents such as deep learning, reinforcement learning, unsupervised tasks, and so on and so forth. So this Python programming language has gained popularity in the 2000s because of its simpler syntax and it's flexible and used across various platforms. Now, the history of Python. Python was developed by Gordon van Rossum in the late 80s and early 90s at the National Research Institute for Mathematics and Computer Science in Netherlands. Python was used to drive many other programming languages, which includes ABC, Modular 3, C++, Algol 68, Smalltalk, C, Unix, and other scripting languages. Python is copywriting like Perl. Python source code is now available under the GNU General Public License, GPL. So Python is now maintained by core development team at the institute, although Gordon van Rossum still holds a vital role in directing its progress. So Python 1 was released in November 1994. In 2000, Python was released. Python 2.0 was released. Features of Python. These features include: 1. Easy to learn. Python has few keywords and it has a simpler structure and a well-defined or cleared syntax, which allows students to pick up the language quickly. It's easier, simpler syntax. The syntaxes are more or less English words. They're compatible with English language words. So they're easier to remember, easier to use, and easier to apply. Another thing is easy to read. So Python code are more clearly defined and visible. Because of their simplicity and closeness to English language, Python code is easier to read and comprehend for English language speakers. Also, it is easier to maintain. It's easy to maintain. Python source code is fairly easy to maintain because of its simplicity and the syntax errors can easily be identified. And another feature, Python has a broad standard library. So Python's bulk of library is very portable and cross-platform, compatible on Unix, Windows, and Macintosh. So if you look at this term, what we're trying to say at this point is Python has broader usage across various platforms, such as Windows, Unix, Linux, Macintosh, and so on and so forth. And another feature is interactive mode. Python has support for an interactive mode, which allows interactive testing and debugging of snippets of code. So this is mostly for programmers working in different domains. So this interactive mode enables them to work together as a team to be able to achieve their projects. So this interactive mode make their job seamless, easier to understand, and easily to move in. So now that we've introduced Python, the historical development, as well as the features of Python, there's a need to understand some interpreters, the meaning of these interpreters, how it works, how these codes get to be interpreted. So, furthermore, other features of Python, it has good, it supports functional and structured programming methods such as OOP. And it can also be used as a scripting language or can be compiled to bytecode for building large applications. So, this Python, it provides high-level dynamic data types and support dynamic type checking, where it also supports automatic garbage collection. It can easily be integrated with other programming languages such as C, C++, COM, Activate, Cobra, and Java. So part of what made Java popular in the 2000s is because of this easily integration, because Python can be used across different platforms and it works which eliminate or reduce the issue of machine dependence, unlike when you compare like machine learning, I'm sorry, assembly language. So now let's now understand interpreters and compilers. So two kinds of application process high-level languages into low-level languages. One, we have the interpreter, and two, we have the compiler. This interpreter reads high-level language program and executes it, meaning it does what the program says. It processes the program in a little at a time, meaning one after the other. Alternatively, it reads lines and perform computation. So it does the interpretation line by line. So it receives the source code written in high-level language, interprets it line by line into the intermediate representation of that particular language. So this intermediate representation are later converted into machine learning. Oh, sorry, I'm saying, pardon me, into machine language representation. Now, a compiler reads program and translates it into a low-level language, which can then be run. So what the difference between compiler and interpreter is compiler does this one at a time. So the high-level language called source code language are translated into what's called object code or the executable file. So once a program is compiled, you can execute it repeatedly without further translation. So this is one of the advantages of compiler. Once it is compiled, it executes repeatedly without any further translation. So and pictorially, it can be represented as. So this figure shows the source code passing through the compiler. It creates the object code. This object code will now be passed to the executor, and this executor translate them into the respected output. So it can see that different languages, and many of these modern languages uses these processes. They first compile it into a low-level language called B2 code, and then interpret by a program called a virtual machine. So Python uses both processes, but because of the way programmers interact with it, it's usually considered an interpreted language. So there are two ways in which this Python interpreter can be used. We have the shell mode and the script mode. In shell mode, you type Python statement to the Python shell, and the interpreter immediately prints the results. So in this course, we'll be using the IDE called IDE, meaning Integrated Development Environment, called idle. When you first start IDE, to open an interpreter window. So the first few lines identify the versions of the Python being used as a first order message. You can easily ignore the lines without the file. So next, there is a line identifying the version of IDE. The last line starts with this, and which is the Python prompt. So the interpreter uses the prompt to indicate that it's ready for instructions. So if you type 1 + 1, the interpreter will reply 2 and give us another prompt 2. So now we've seen how these things works. Now let's try to see how we can set up the Python for usage. So to start coding in Python, you install the Python from the official website, python.org, and set up an IDE such as PyCharm or VS Code, or you can also use Jupyter Notebook. So I think for this class, I think we're going to be using the VS Code subsequently. Since we're at the introductory point, it's good that I prepare your minds on this aspect that we'll be using the VS Code for throughout this course. Now, to run a Python program, there are 3 different ways to. One is through the interactive interpreter. You can start Python from Unix, JS, or any other system that provides you with a command line interpreter or shell window. So you can try this from shell window. For those of you on Windows system, you just hit the command line and type -- you type the Python to know the Python version installed on that system. From that point, you can be able to execute simpler instructions such as 1 + 1, 2 + 1, 3 + 2, as we earlier explained in the previous slides. So another method is script from the command line. You can also use the command line. Mind you, PowerShell and command line do have similar function. So you can also do the same. You can also use the IDE, Integrated Development Environment, such as the Visual Code, the PyCharm, and others. So this is a very important component that we need to know. First, before we talk about debugging, we need to know bugs. So bugs are just errors in the programming language or programming errors. They are referred to as bugs. And the process of tracking them down to correct them is called debugging. So three kinds of errors can occur in a program. For every programming language of every a programmer will tell you that there are expectedly three kinds of errors in a program. One is the syntax error. This syntax errors refers to the structure of a program. Sorry, syntax refers to the structure of a program and the rules about that structure. For example, in an English language, a sentence must begin with a capital letter and end with the period, which is a full stop. So this sentence contains a must end with the period. So this sentence contains a syntax error. So another one is the runtime error. So the second type of error is a runtime error. So called because the error does not appear until you run the program. So runtime error it comes at the end of program execution. So because after you don't know if there is a runtime error until the program is run, that's when at the end you now notice. Although these errors are also called exception because they usually indicate something exceptional and bad has happened. So one may not see the runtime errors until the execution has taken place. Another form is the semantic errors. So this third type of error is the semantic error. If there is a semantic error in your program, it will run successfully in the sense that the computer will not generate any error message, but it will not do the right thing. It will do something else. So that is a semantic error, meaning what the program was meant for. The program will run successfully, of course, and give out outcomes, but will give out unexpected results. So this kind of error is called semantic. While runtime error occurs during program execution, while syntax comes when the structure when there is a violation on the structure or syntax of that particular programming language. These structures, of course, you should know we are referring to the rules governing that particular programming language. Now, let's now look at variables, objects, and classes. We know a variable is a reference to a value stored in a computer's memory. Variables can be stored into a variety of categories. They can be stored as data types, as numbers, which include int or float types, can be Boolean values, and it can also be a sequence, which is string, listing, arrays, etc. So an object is a collection of data from a computer's memory that can be manipulated. So object collection of what? Data from a computer can be manipulated. And you all know that all variables are objects, although some objects can be defined by data reference to by multiple variables. So and the method, which is also crucial, are the functions used to act on this object, or they are used to alter the object data. They are used to purposely define or describe what your object can do. So now, what is a class? We now know that we've known the meaning of objects, we've known the meaning of variable. Now, a class is a collection of objects who share same set of variables or methods. It is a collection of objects who share the same set of variables and methods. And the definition of class provides a blueprint for all the objects within it, which are also referred to as instances. So instances may share the same variables, color, size, shape, etc., but they do not share the same values for each variable. So look at the example on the right-hand side. You see, the class is been defined as the car, but the object of the class can be the Polo, can be the Mini, can be the BT. So and the instances can be the pink Polo, Mini, the color can be red, and another instance can be BT. The color will be blue name. So you see, they shared the same class, but they did not share the same values. You can see that in the sense that their colors are different, but they are instances of the same class, but they did not share the same values. So this example is just to further explain that statement that we said that they do not share the same values for each variable. So now that brings us to the end of this introductory class of Python. However, there are some quizzes for you to look at. These are some of the quizzes. Try to make an attempt to these questions rather, to be able to assess yourself based on the understanding of this particular class. So we shall forge ahead to look at the next lecture. For now, bye-bye.